So now that you've watched the video of the bungee jumpers, I want to go over real quick the different types of energy that a bungee jumper would have in different positions. So right here I'm going to use this rubber band as an example of our bungee cord. So I'm going to go ahead and draw a picture of 4 different positions that a jumper could be in. 1, 2, 3, 4. We're going to label these A, B, C, and D, just so I can refer to them really easily. So here I have a bungee jumper who's at the top with the whole thing, with the whole bungee cord all wrapped up. Okay? So this is going to be A. He's looking a little bit scared. Okay? I know it's not a great drawing. It's the best I can do. Alright, so this second one right here, we're going to have a big thing of bungee cord right here that's connected on. And we're going to have the person about halfway-ish down. Okay? The cord is connected right there. Okay? Then the third one, we're going to have the person, the bungee cord fully extended, and we're going to have the person basically at height 0. Right? The person just barely scrapes the ground, which isn't what you want to do when you're bungee jumping, but this is what the picture shows. This person is neither going down nor going up. Okay? This person's going down. There is no movement on that one. This last one, we're going to draw a person that's on their way back up. Alright, so now I want to go over what types of energy each position has. Go ahead and take your time. We've learned about kinetic energy, which is the energy of movement. Then the different kinds of potential energy. We've learned about gravitational potential energy, and we've learned about elastic potential energy. Gravitational potential energy being the energy that's stored in an object because of its position, which over here would be the height. Or elastic potential energy, which is because something's been stretched or compressed. Go ahead and pause the video and label the types of energy each one of these has, keeping in mind that it may have more than one type of energy. Pause the video and then come back after you've written them out. Okay, this person right here is going to have gravitational potential energy. They have this because they have height. They are off the ground. They do not have kinetic energy because there is no movement. And they do not have elastic potential energy because there's no stretch. Keep in mind, some of you are going to write on the assessment that a rubber band has elastic potential energy. This rubber band sitting right here does not have elastic potential energy. Now that it's stretched, it has elastic potential energy. But if it's just sitting here not stretched, it does not have elastic potential energy. Now if I go ahead and stretch it out, it has elastic potential energy. Then when it's moving, it has kinetic energy. Right? On its way down while it's moving, it has a little bit of elastic potential energy left. Okay? Now, this second position right here, this person is still off the ground, so he still has gravitational potential energy, but he also has kinetic energy. He does not have elastic potential energy yet because when the bungee cord is going out, it hasn't been stretched yet. It's just simply feeding out, but we haven't stretched it yet. Right here, this person is on the ground and they are not moving up or down. So there will be no kinetic energy because they're not moving at all. They're in that split-second stop at the bottom. There also is no gravitational potential energy because they're on the ground, height 0. If there is no height, there's not going to be any gravitational potential energy. But that bungee cord is very much stretched out. So this person is going to have elastic potential energy. Then on this last one, on D right here, this person is off the ground, so they're going to have gravitational potential energy. They're moving upwards, so they're going to have kinetic energy. And there's still some stretch. This bungee cord is less stretched than it was before, but it's still stretched. So they're going to have elastic potential energy. I'm just going to write EPE for elastic potential energy. Notice how the types of energy change throughout. Later on, we're going to learn that all of these always add up to 100%. Okay? Email me if you have any questions. Let me know.